odd moment happened around 13 years ago, when through a friend of a friend, I met a guy who was a solar panel installer. I was intrigued by this new mysterious technology that could convert sunlight to electricity with no moving parts, made from abundant materials like silicon, glass, and aluminium, and would just sit there quietly day after day, making no fuss, producing clean, green, renewable energy for use in my home. Three things converged for me at this time that set me on a journey that has continued to this day and inspires me to get up every day to do my best to help solve one of the hardest and most intractable problems facing society, and that is climate change. With my years of training, more than 1 year, it was a career, in finance and analysing businesses, I became convinced that solar PV would soon be able to generate electricity way cheaper than traditional forms of electricity from coal and natural gas, and that this technology would outcompete the traditional generation on its own merits. My passion for science, which I left behind at the end of school, was rekindled. I fondly remember enjoying physics and chemistry at school, and I got to re-establish that in my new passion for renewable energy. I learned about the photovoltaic effect again, first discovered by French physicist Edmond Becquerel back in 1839, that could convert sunlight to electricity when sunlight struck a certain metallic substance and you created a circuit. And thirdly, my growing awareness and concern for climate change, inspired by Al Gore in his seminal films from 2006, An Inconvenient Truth, got me really thinking and worried about my children's future with a young family. There's a very unassuming weather station on the northwest tip of Tasmania called the Cape Grim Baseline Air Pollution Station. It's one of only 3 weather stations in the world that is able to precisely measure the atmosphere's concentration of greenhouse gases like carbon dioxide. And what makes it so special is that when the wind blows from the southwest, it's uninterrupted for over 3,000 kilometres as the wind crosses the Southern Ocean without human interference. For around the past 800,000 years, about as far back as scientists can reasonably measure, CO2 levels have varied between about 200 and 300 parts per million. That's the left-hand chart. The right-hand chart shows what's happened more recently, where since about the Industrial Revolution between 1750 and 1800 was just kicking into gear, human activity has raised the level of CO2 in our atmosphere far above historical norms. Looking more closely at the last 100 years and looking at the recent data, we can see a continual trend upwards. As every year we dump 37 billion tonnes of CO2 into our atmosphere as if it were an open sewer. My parents, who are in the audience today, were born at 310 parts per million. I was born at 327 parts per million. My daughter Emily was born at 386 parts per million. As we sit here today, we're at 418 parts per million. And every year, parts per million rises by 2 to 3 parts per million inexorably. The sad reality is that humanity is addicted to fossil fuels. And for all the talk and shaking of heads and fists, we've not yet been able to turn this trend around. There's a direct relationship between the levels of CO2 in our atmosphere and global average temperatures. The science is unequivocal. Last month was the hottest September in recorded history, beating the previous margin by 0.5 degrees. This would be like Usain Bolt at his prime, losing out to somebody 10 meters ahead of him. Simply unimaginable. Yet with all these terrible facts, science and evidence, I remain optimistic that we're going to solve this problem. 5 years ago, as you heard, I was appointed as the CEO of ARENA, Australia's renewable energy Regulation Agency. With a budget of $4.5 billion, ARENA has been investing in the latest and most important renewable energy technologies with the objective of making renewable energy the cheapest option, seeing it displace fossil fuels in our economy and helping us to achieve our climate targets. To date, ARENA has committed $2.3 billion to over 660 projects right throughout Australia, like large-scale solar farms connected to batteries, pumped hydro schemes, the GenX pumped hydro scheme in central Queensland, the first privately funded pumped hydro facility in 35 years in Australia. Large-scale batteries, like the Tesla Big Battery in South Australia, and ARENA has gone on to fund about a dozen of these right throughout our country. Innovative solar thermal projects like this ReddamHouse project in Mildura, which I opened up with the Minister for Climate Change just 3 weeks ago. Innovative EV charging to allow us to buy electric vehicles and confidently use these vehicles and charge them right throughout the places that we live and work. Hydrogen electrolyzers, like this very first of a kind electrolyzer in Jandakot, a suburb of Perth, which we opened up in 2018. And even the very dirtiest plants in our economy, an alumina refinery in Gladstone, which we're converting to use clean green hydrogen. And this is a photo I took on the hill there earlier this year. And very importantly, steel making. This is the bottom of the blast furnace at Port Kembla, one of 2 giant steel making facilities that we have in Australia. And many people don't know that Australia makes 40% of the world's iron ore, the core ingredient that goes into steel making. We only produce 0.3 of the world's steel. We have a huge responsibility to figure this out and get this steel making process converted into a green alternative to fossil fuels. But for all of this important technology and innovation, we need to return to my light bulb moment, solar PV, and talk about the fundamental importance of this technology to our future. Not just its role in helping to solve climate change, but its a crucial role in helping our economy to modernise and for Australia to continue to be a successful economy way into the future. We all know that our economy today is based around fossil fuel extraction and heavy industrial processes. As the world decarbonises, as it must, our fossil fuel exports are under threat. However, our role in supplying the world with its ores and minerals that it needs will continue, if not grow. New commodities like lithium, cobalt, and rare earth elements are growing in importance, and traditional commodities like copper, aluminium, silicon, and of course iron ore will still be needed by the growing economies of Africa and Asia. It's crucial that this demand is met in a low carbon way. And this is where Australia, with its world-class solar and wind resources and large available land mass, can play a massive role. You may have heard people talk about Australia as a potential renewable energy superpower. This is all about using our renewable energy resources to make new products like green iron, green alumina, and green hydrogen for export to the world. Hydrogen from electrolysis is a very important technology that allows us to ship our sunshine to other parts of the world in the form of liquid hydrogen, ammonia, which is a derivative of hydrogen, or methanol, or even by subsea cable, like some people are trying to do all the way to Singapore. Extremely cheap solar at massive scale lies at the core of this vision and ambition. We must be able to generate the flow of clean electrons at extremely low cost, and solar provides the best opportunity for us to do this. We already have some of the best researchers in the world at the University of New South Wales, just up the road from here. Solar costs are on a very predictable decline. In fact, in the last 10 years alone, solar module costs have declined by almost 90%. Researchers, the likes of which we have in Australia and overseas, are working on new materials and new ways of extracting even more energy from sunlight than we do today. Current solar modules convert about 22% of available energy into electricity. And we're working to get that up to 30% by 2030. We're looking at new ways to install solar in the field. Today it costs around $1 per watt or $1 million per megawatt to install solar in the field. We think we can get that down by 70% to 30 cents per watt. And again, we think we can do that within the next decade. And if we can do that, solar will be literally dirt cheap and will be the fundamental building block to our superpower vision. 13 years ago, we installed a 6 kilowatt system at our home in Bellevue Hill. Last month, as part of a renovation we're doing, we upgraded the system by doubling the number of panels, but quadrupling the energy capacity to 25 kilowatts. But what's even more impressive is this 25 kilowatt system, using modern technology now 4 times higher capacity than the system we installed 13 years ago, is actually cheaper than the system we installed 13 years ago. And this is why I'm optimistic that technology will be the thing that can help solve climate change. As technology matures, it gets cheaper. We've seen this with Moore's law in computing, and this pattern is playing out with solar, wind, batteries, hydrogen, and electric vehicles. The new technology is better, faster, quieter, more reliable, cheaper, and cleaner, and this pattern is set to continue. At the core of all of this is humanity and the power of the human mind. We are our own worst enemies and our own saviors at the same time. Human nature is such that we all want a good life, full of fun activities, good food, travel, clothes, and shiny new things. All of this requires the harnessing and use of energy. For most of human history, we haven't had to care about the consequences of this energy. It was mainly about survival. And since the Industrial Revolution, we've had access to cheap and easy energy from coal, oil, and more recently from gas. But now we know the consequences of burning fossil fuels. We need to make the switch to clean energy from the sun, wind, and water. Humans are capable of so much. We have invented rockets that can take us into space, computers that let us compute and connect, and planes that let us travel around the world. And humans have invented the solar panel that will let us carry on our journey in a sustainable way. This is our light